everyone. We are here at the COP28 with eminent young people with me, and we are organizing this small chit chat, I would say, not a panel. We are sharing our ideas, what we are going around in the nuclear industry, fusion industry, and what role we can play together. And this is being organized by IYNS, the Indian Youth Nuclear Society, in association with Nuclear for Climate. And we are thankful for ITER organization for giving us a space for all of it. And to begin with, I'll start with my introduction to all. So I'm Nitendra Singh, working at ITER organization, and I am the founder president of Indian Youth Nuclear Society, and we are working in the area of outreach, education, innovation, and fusion technologies as well, and climate change solutions in that direction. And to begin with, I'll ask all of you to please introduce, and then we can continue.
Okay, hi everyone. My name is Prasoon Raj. I work with Commonwealth Fusion Systems (CFS) in US, and before this, I was working here in the UAE as an environmental radiation physicist with Khalifa University and Emirates Nuclear Technology Center. So I have a bit of mixed fission fusion background, and I think I'm happy to hear a lot, but I think we all align on the simple message that we need nuclear, and developing countries like UAE, India has a big role to play in this. So, yeah, that's my brief introduction, and I'll pass it on to you.
Thank you, Prasoon. And thank you, Nitin, for setting this up, little chit chat. I'm Gunjan Indauliya. I work at Atkins as a radiation shielding specialist. I come from a fusion and fission both backgrounds. I worked for ITER as an electronic scientist for 3 years. Then I had my own startup in energy sector, and then now I'm working as a radiation shielding specialist as well as a nuclear safety engineer with a lot of power plants in the world, mainly EDF plants in UK as well as Baraka nuclear power plant. And yeah, happy to be here.
Hello everyone, I'm Feliciano. I'm from Portugal, and I am the co-founder of Nuclear Vision Portugal. I came here invited by Mark Nelson and Net Zero Nuclear, and I came here basically, and following with what you just said, I came here to raise a bit of awareness on nuclear energy in general. I'm also a student of physics engineering, and I'm interested in fusion. I may pursue it as my career, but for now I'm finishing my bachelor's, and that's about it.
Hi, my name is Miguel Trenkel Lopez. I started my career in nuclear decommissioning in the UK, and since then I have been working for my own company, communicating about energy and climate change. And I'm here at COP with Nuclear for Climate, so I'm one of the leads for Nuclear for Climate, organising a youth-led volunteer group talking about nuclear to delegates in the Blue Zone.
Thanks, Miguel. I feel happy to mention always that IYNS was one of the founding signatory for Nuclear for Climate in 2015 during COP21. And actually, I'll start from that journey itself. So 2015, the COP21 was first time when we were actually trying to push for nuclear to be included in the discussion. We were trying to mention that it is the part of solution and we should at least talk about it. And before that, nobody was actually including a nuclear as a part of solution in any documentation. And even when we proposed this in COP21, it wasn't the part of the final declaration yet. But the journey started, and today we have come far ahead, I would say. Far ahead. Why? Because when the COP started during the plenary session, we saw, we have a nice background music, by the way. It's helping to set up a good nuclear mood, I would say. So we started a good journey at COP. We had a big announcement coming from all nations joining together, a big number of nations, I would say 40 plus something, for tripling of nuclear power plant and nuclear energy in their country to be the part of net zero. which is really remarkable. And as well, the White House announcing the Global Fusion Directive or Global Fusion Policy, where fusion should be um, deployed at a faster rate, and what sort of challenges are coming, how we can create that sort of ecosystem for having the sustainable companies for in the fusion industry and things like that. So let's begin with that. I mean, you guys are already advocating this from different organizations, but the same message that nuclear, whether it's fission or fusion, have its own role to play in a different timeline, in different way. So what do you think, how youth can contribute to this perspective? So yeah, you want to? Yeah, sure.
Yeah, I guess I could just start with a little bit of the history of nuclear for climate, a little bit more context. So, COP21 was when it started, but I found out a couple of years ago that back in 1999, Sama Bilbao, Director General of WNA, was at a COP4, and they had a very small booth, and there was some advocacy back then. So we weren't the first ones to do it, but I think it kind of fell apart and never really was consistent at any COPs until Nuclear for Climate was started in COP21. I know from 21, 22, 23, 24, 25, we weren't really part of this conversation. I wasn't there until COP26, but from what I understand from the organisers, we'd never had a booth. Sometimes we weren't allowed in the building. We weren't really considered to be taken seriously. COP26 was the first year that we ever had a booth, and we had a fantastic team in the UK organising Nuclear for Climate. And that's where a lot of things that we still see today are happening. So you'll see the blue T-shirts started at COP26. Giant Bella the Gummy Bear, which is about energy density, started at COP26. And I think since then, COP26, there was one nuclear booth. IAEA didn't have a booth. They just used the shared space sometimes. COP27, there was IAEA Atoms for Climate and Nuclear for Climate. And I think there was also an ITER. Yeah. ITER was part of IAEA, that's it. And now we come to COP28 2 years later, and there's 3 nuclear booths in the blue zone, there's a nuclear booth in the green zone. The tripling nuclear capacity would have been unheard of 2 years ago at a COP. So I think we've come really far, and hopefully Nuclear for Climate has played a small role to support that, because the reason we wear these bright blue T-shirts is because in the past, advocating for nuclear is quite controversial, and a lot of people secretly supported nuclear but didn't want to express it. And we kind of made it something that was proud to think about nuclear, and these guys aren't ashamed that they support nuclear. And I think that's really helped open the conversation, and our message here at COP is together is better. So we want nuclear to work with renewables to end fossil fuels, and that messaging really resonates with a lot of people here. And we're not trying to fight against the renewable industry. We want to work together because 100% renewables is very difficult, if not impossible, or at least not desirable. You know, the amount of overbuilding, the amount of storage, it makes it a lot more difficult. So then we need to think about baseload, and that's where nuclear is fantastic. So it's been a great journey, and it's just great every year to see more and more representation for nuclear here at COP. You want to add anything? You want to do it first? Go ahead.
I would like to add to what Miguel said. Like, I'm membership lead for women in nuclear, and I've seen young generation, global young generation, and I've seen the transformation within 2 years. There were very few members in the team, joining women in nuclear organizations. Now we see a lot of representations from the country which do not have their nuclear programs yet there, but they are looking towards it. They are advocating for nuclear. So we have women from a lot of women from Africa, all over Africa, many countries in Africa, Middle East, which is really exciting to see. So many youth representation, and that global from, and we have different perspectives around. I have met many young people, and they have many anti-nuclear sentiments. However, the good part is that there are many nuclear advocates now who were anti-nuclear 2 years before, but now they are talking for nuclear. They transformed. So see, because of nuclear advocates like Miguel, they are transforming the thoughts of people, and and more people are advocating for nuclear. And it's as he clearly mentioned, that it is very important to nuclear energy in the clean energy mix if we want to be there to reach net zero by 2050. It is only possible when nuclear is included in the clean energy mix. So yeah, that's my take on it.
Okay, I'll try to talk a bit about the question you asked, what more youth can do. We already heard a lot that we are doing. I think one of the core reasons we are still here where we are asking people to accept nuclear is that there are a lot of myths around nuclear which have been traditionally been there in industry, different industries, in society, and they still are there. So if you travel across the world, there are very frequently people asking you or questioning you on some of the issues with nuclear. And I am sometimes amazed that after so much of social media, after so much of information boost everywhere in the world, there are still people who are unaware of facts about nuclear, who are still asking whether it's can be a part of the solution or not. I think if more and more of us are vocal, in our social circles, in our smaller day-to-day circles, and try to project simple ideas that, yeah, okay, radioactivity, but what about it? Like, let's discuss it in more details. So that's an example, but there are a lot of such issues which have been lingering around for centuries and, sorry, for decades. I'm going too far in history, but it's this time, it's this like couple of years when we should really like make it clear that okay, these are all myths. Let's get beyond those and start working on the solution collectively. And I still feel very amazed when someone randomly asks me questions where I'm like, oh, this should have been answered to you in the high school, but it's still not happening. I really feel so.
Building on that, I truly believe that we should get to talk more about nuclear energy and debunk some myths. And I feel like a bit after Chernobyl, what happened, if you see the charts, it's quite funny to see that like in the years before Chernobyl, we were building new reactors and putting them to work. Then Chernobyl happened and like we stopped making, basically. If you see, it's like +1 -1 +1 -1. And so nuclear energy has basically been this source that has been in the background, silently waiting for the time to come back, powering our nations, some of our nations, getting a baseload stable source of energy, electricity. And just now we see that we have maybe another chance to increase their potential to bring a different life without carbon emissions, because that's like the thing we all agree on, right? We want energy without carbon emissions, and nuclear is an important piece of that puzzle, because for a while we have been trying to make a puzzle where we had solar, wind, some kind hydro, but hydro is a bit of, it depends on how lucky you are. Like if you are in Norway, you can have 100% fuel or 90%, 80% fuel from hydro, and you don't need basically anything else. Everything else is extra. But if you're unlucky and you live in a dry country where it doesn't rain or where there's no mountains to catch ice and let it melt, if you don't have the right conditions at birth, you need some sort of reliable power. And that's where I believe that nuclear comes in and shines bright like a star. Not like a star because a star does fusion, but that's what we will discuss in a bit, and I'll leave it for you.
We are on the way of this shining star in any case. But one thing you have highlighted about the other sources as well, which is really interesting to point out, that whatever we are having on our planet, it is actually a secondary source. Because the primary source is fusion, which is already taking place in stars and in sun, the closest one. And because of its radiation energy, what we are receiving on planet, we are actually converting that only. So if you can tap that primary source, then why not? And that's where this fusion plays a key role, and there have been many breakthroughs in that area as well. What do you think about these recent breakthroughs? Maybe you can mention something.
Yeah, I think one of the biggest breakthroughs, if you are seeking information, is that high temperature superconductors are becoming feasible. That's going to change the world of fusion dramatically, because uh, the the approach to having a power scale fusion is using bigger and bigger machines. That's what ITER represents, like having a huge tokamak which produces sufficient reaction to have a good amount of energy production. But with a stronger magnetic field, you can have more compact reactors. That reduces the footprint you have of the reactor, and so you have more, let's say, an easier scalability in that sense. So that's one big breakthroughs, but that's not it. Like, we have understood, uh, thanks to the dedicated work of tokamak and plasma physicists and physicists who are working on fusion worldwide, we have gotten answers, or at least hints at most of the big problems which is stopping fusion from being practical power source. And so there are claims in the industry, if we are ready to call it an industry, is that we can so there are claims in the industry that we are ready to join the power production business as soon as this decade. But if you want to take a more physicist, more scientific approach, there is a good bunch of force which is ready to demonstrate it in next couple of years, that we are ready to have net power production from fusion on a scale that can lead to a power plant design. And so I find that very exciting, that we have credible scientific proof. We have good investments coming in, fingers crossed. That's been very recent. And a lot of young people want to join. Like, I'm surrounded by people of my age group, so I feel the buzz that everyone wants to join the industry, wants to join the force, the movement. So that's in summary. I think I forgot to mention that Livermore, the Lawrence Livermore Laboratory last year announced a breakthrough that, in terms of physics, they are able to produce a net power out of a fusion reaction using the National Ignition Facility. Now we are paving the path towards doing that on a industrial scale, on a scale where you not only have physics net energy, but also net energy engineering wise, so that you can extract something out of it and start producing electricity. So I must say it's an exciting time, and I was really excited after the announcement in COP28, which I have been observing from outside. That it's a great time to be in. It's a great time to be in nuclear industry, because when I say nuclear industry, I'm talking about everything. There is a big overlap between fission and fusion. There is no denying that. I myself come from fission background, so we have to keep that, the osmosis. Yeah, exactly. We have to focus on developing that synergy if it's missing. But I honestly don't think it's missing. But yeah, there are a lot of debates about it. So,
Yeah, that's right. It's an incredible time, and I have met a lot of people in COP. And when I talk about nuclear, it's not. There are few who do not know about it, but there are many who know about it, and there are all the myths around red waste. They are pretty much concerned about red waste. They might not be having any idea about it, but that's what they know about it. That nuclear, we should not use nuclear because it has red waste problems. And it's not just anyone, policy makers. I have met people who have climate change rated foundations, and when I was they were doing rally over here, and I joined them. And when they were talking about like solutions like solar, wind, and when I said nuclear, they were like, no, shh, it's very controversial, you don't say it. I was amazed, because that lady was in the climate sector for like 20 years, like 2 decades. So yeah, it's very hard. And when I had another conversation with a lady who is an environmentalist, and she was very much concerned about red waste, and I tried that if I can change her perception, but it's very hardwired. She's like, I have read it, I have read this, and like it's very hardwired, so it's very tough to change. So the good thing with fusion I really like about it is that it does not produce red waste. One of the biggest concerns about nuclear fusion industry is red waste. And if we are able to crack nuclear fusion, which we are very close, and I'm very, very positive about it, then there's no way back. Nuclear is gonna be the solution. Nuclear fusion, tap on that. That the problem is red waste, and nuclear fusion solves it. There's no red waste. And it's inherently safe, like that. Other problems, it solves other problems as well. So I'm really excited. We are there. Like fusion was like talk of future, but no, it's not anymore. So I'm really excited. Yeah. So I'm really happy. Yeah, absolutely. I hope that the future is bright for us.
Can I just quickly challenge something? Because my understanding was that fusion still has a fair bit of intermediate level waste. So you don't have spent fuel, you haven't got the 100,000 year kind of fuel that you need to recover, but the neutron bombardment within a fusion plant is actually much higher than in a fission. And so the materials, kind of, from what I understand, become radioactive, and you have to deal it as like the same kind of waste as the majority of nuclear. So I think there is still waste challenges.
I get that. That's a very important concern. Again, we have to answer all those concerns. That's a very important concern, and it's coming from a person who's already in the nuclear industry. I worked as a radiation shielding specialist, and I worked for the red waste. I did the calculations to calculate that after all the reactor operations for fusion reactor ITER ended, how much will be the red waste. So since most of the structure gets irradiated through neutron, and it's majorly steel, and which has cobalt-60. So we do not have uranium, we do not have spent fuel, and that's one of the important concerns. Spent fuel, uranium, plutonium. We can deal with intermediate level waste in a much easier way as compared to the spent fuel. So your concern is very right, but still handling of the waste becomes easier when it's not the fissile material. So that's why my
There's
thing
more
is.
scope of reuse, recycle as compared to fission waste.
Yeah, he wants to add.
It was just to say that's an example of where skills from fission can be transferred to fusion. So people that are building fusion reactors probably don't have the experience of decommissioning that the fission industry has decades of, and that's where the transfer of skills is really important.
Absolutely.
Sorry.
Right now we are in the phase of commissioning, huh? but the decommission is still planned, and that's where this study makes a very relevant part. So fusion, because of this high energy neutron system, is targeting to have material which has low activation components. So low cobalt or no cobalt, that sort of reduced activation ferritic steel they are developing and things like that. Low active materials we are trying to, and this is one of the challenges as well, because developing a new material is not just an easy process. It takes a while, and even if you develop it, if you are developing in a, say, 1 centimeter square thing, it's a different thing. But when you are making it a big, like one vacuum vessel sector we have at ITER is close to like 2 Boeing 747 airplanes, and we have 9 such. So when you're talking about this sort of scale, there's always something new. Even with the existing steel we have, we found there are some different challenges which we didn't imagine in this beginning, or they were not captured in the simulations, because the fusion data is very much low for that sort of understanding further. But this is where I think challenges as well as synergies are taking place commonly in both the fields. So I myself is also belonging to the same background. I started with fission industry, did severe accident research was my specialty, and still I'm working on the accident scenarios for tritium rhodium blanket system for fusion. So it's very relevant field for each other to help each other to grow. So in that sense, if you see, the I always say the skill synergies of skill is very much there, and this will also be required for having the scale up factor what we are talking about in tripling of nuclear project, or having commercial fusion as soon as possible. And you have rightly mentioned the funding is one of the issue. In one of the panel yesterday we have at Clean Energy Task Force, this was one of the prime thing, and one of the expert mentioned, if we give us a required funding for fusion today, you can have a commercial fusion tomorrow. It seems different and seems what we are talking about, but this is the scenario. Fusion has already always been underfunded, I would say, or has been always seen as the research project or a scientific project instead of a industrial development or power plant, that sort of thing. I think it's interesting to have a perspective from youth side, what you think and what we should do to encourage people, because two aspects which I all found in both the industries. One is a lot of youth is not actually coming. What we see a buzz, it's one part, but there is a huge gap in the youngsters to join nuclear industry, because there are many parameters. Of course, if you are good, you will get a good job at any multinational IT or somewhere with a good package. Then why you want to invest your time and energy and your brain in this sort of thing? This is one. But there is another aspect where I always focus, that we have a very less representation of women in the STEM in general, and when it comes to the specialized field like nuclear or fusion, the number also keep on decreasing. What do you guys think that we should do to bring it bring a change in this direction? What we are doing, I'll tell you that at IYNS we are trying to have more nuclear education, energy education, or STEM education, or at IYNS we say STEAM education program for young schools, the high school students, and connecting them with the university students to have this synergized education system, which is very much related to current problems of the industry. So this is what we are working on for a couple of years now, and from next year onwards we are planning to have it with more schools globally, internationally connected. So this is what we are trying to think and proceed with. Maybe what are your take on this, if you want to add?
I can try. So, you were talking about how can we bring some people into this. And one thing I've heard talked about in the scope, and that is quite true, is that like we all, I believe, we all have electricity at home here, and when you turn the switch, it goes on, right? Like there's this amazing machine behind it that makes sure that it is on, okay? And we usually see it, but when we go around we may see some wind turbines and some solar panels because they have to be everywhere, and that is, whereas like a nuclear power plant is so small that if people don't know that it's there, they will not look and don't get the exposure to how nuclear energy works and what can it do for us. So if we just realize that nuclear energy has been like in the background and kind of forgotten in a way because it doesn't have the same needs of space as the others, and so the others may attract more people because they are like advertised, because you see them wherever we go with our cars and some things like that. Other things that we can do are education for sure about what nuclear energy is, how does it work, and how, but in very simple terms, it is just another way to heat up water and make a turbine spin. That's just it. It's much harder than that, but in the end, it goes back to that. When you get the turbine spinning, you get electricity, stable, reliable, green. Whereas the other ways we have to do it nowadays are gas and coal mainly, and or hydro. But and those cases have the carbon and coal and gas have the CO2 emissions, which we don't want again. Yeah, I believe this is one take. Does anyone else want to talk a bit about it?
Yeah, so in the UK curriculum at schools, the key learning point is renewable technologies and non-renewable technologies. So you've got wind, solar, hydro on one side, and you have fossil fuels and nuclear. Good, bad. And
That's interesting already.
so it's a challenge to kind of go beyond that sometimes and recognize that the word renewable does not mean clean or low carbon, and it doesn't mean that that's the only sort of form of technologies we use. And I mean, we're talking about renewable in the sense of fuels, right? But if we're talking about mineral use and material use, if we fully recycle all wind turbines and all solar panels, then it's renewable in all senses of the word. But that starts to get a little bit more complicated, and it's not really communicated in schools. So you've got this kind of two buckets, good and bad. So that's kind of why I started my company. So we made a game called Megawatt. It teaches about energy and climate change. So students have to build an electricity grid using all the different sources of power. And as the game goes on, events happen that challenge you to kind of understand the advantages and disadvantages and how it relates to climate change. And in this approach, when you look at it as a system and you're trying to build a resilient grid to mitigate against all these things that might happen, then you start to realize, oh, this is why we need something like nuclear. And it's important to talk about it in that context rather than as a sole technology, I think. So understanding the reasons behind it. So yeah, that's kind of some of the stuff I've been doing.
Oh, I would like to add that yeah, education is very important, because people tend to listen to myths more quickly than the facts. Okay, and if we have put the facts in a right way in the school curriculum, they are more knowledge about it, they are more informed about it, and when they read opinions of people, they can make informed decision about it whether they should trust it or not. So yeah, it starts at the very first from the school curriculum that they should have class of all the energy sources, and should have one chapter for all the sources describing advantages and not to hide the disadvantages of any source. This is very important to make to be informed about a solution. Solar also has many disadvantages. We do not talk about it. So I think it has to be overall. We should not shy away from the risk associated with the nuclear as well, but we should talk about all the safety measures put in place at a nuclear power plant. So I really believe that countries, at least those are nuclear power countries, or who are willing to adapt nuclear into their solutions, clean energy solutions, should include this curriculum. And we as a youth, nuclear congress, we can start this initiative as well. When we now people listen to us. We have seen many ministries, from Australia and other, US, coming to us, and they have appreciated our initiatives. And I think that we can start one initiative where we can ask governments to include this kind of curriculum in their schools. That would really help to have a informed in understanding about energy sources.
At IYNS, we do this boot camp every year, the education boot camp with different schools. And from 2020, 2021, and this year 2023, we we did this Shivnadri schools and other schools collaborating, and ITER participated as well. This was one of the theme we gave to the students actually. That you have 1 month, you have all sorts of energies you want to explore, but come up with an idea which is good and why. And if you were asked to give an energy mix, what you will prefer, but why is important. And the interesting part was this: those who were doing the surface areal research, they came up with the example Miguel has mentioned: good package, bad package. But those who actually did good research, they found if you actually study the entire cycle, starting to end, nuclear is the only industry, I would say, who's taking care of starting to end product. We take care of our waste, and probably that's why everyone actually noticed that we have a waste. Otherwise, nobody is actually noticing that what sort of waste we have in solar or in wind energy or things like that, because it's like done, okay, solved. But since we are taking care of all our waste we are producing or taking responsibility of it, it's making one of our difference. But this is one thing which we should bring to change. And being youth, very much connected to social media, which is really a power these days, we could bring some changes. And what Miguel is doing to creating some good interesting games would be a thing for this part. One last thing I want to touch before we go conclude the session is this: we always talk about power applications whenever it comes to nuclear. We say yes, we are going to reactors, and now the upcoming thing is small modular reactors for the fast deployment. But we somehow miss there is a long associated thing of non-power applications, the medical industry, the agriculture, and all. And with fusion, which is not yet in operation, but still there is a lot of spin-off research and spin-off output coming out of it. For example, the development of superconducting magnets, which is now being used in many other transportation, in electric smart grids and things like that. What do you think we should do to highlight this part as well? If not everyone is going to go for power application, they should at least consider this for the other benefits under the sustainable development goals, for example.
So yeah, I'm actually still stuck in the thought which was part of the previous discussion, like how more youth and women can be involved in this. And I'm just going back to my experience over there, and actually it very well aligned with your next part, is that when I start to talk with high school students in India, and we also did it here in UAE, is that we start by asking them, what exactly are you interested in? Are you interested in aerospace or mechanical engineering, metals, food, botany? And then you see that if you like take a step back, there is nuclear connected with that most of the fields. For example, the food and increasing the shelf life of food, or increasing the quality of seeds for better harvest, better production. There is such a pertinent and important role of nuclear tech in that, and that's something which is more important than electricity in some scenarios. And we need to start talking more about this. We kind of, as you rightly said, get stuck with the electricity and the big, like, I don't know, business part of it. But then the same technique, the same radiation physics applies pretty well to a lot of other industries. So, yeah, I think we need to start talking to more people, talking to people with varied interests. So, for example, one of the work which I was doing here was understanding how trace level radioactivity transmits in the radiation, and how by understanding or tracking those traces, you can also solve problems of pollution, phytoremediation of pollutants in the soil or in the air. And it then attracts a lot of people who have background in chemistry, or who are more interested in going forwards in the chemistry, because, and it rightfully fits into our agenda very well, because ultimately we are talking about chemistry of heavy metals like uranium or plutonium or thorium. So we are, thankfully, nuclear is like it's like a, let's say, a product of all of these coming together. So we have to be just intelligent, and in the wherever we are talking, we just have to find, okay, what's connecting with nuclear over here, and there is definitely some industry forming around most of those applications. So yeah, I think about this a lot, I must say. Anyone wants? Yeah.
Yeah, like you're absolutely right about it. I mean, yes, nuclear energy has a role to play in clean energy goals. But that is right, and I can give example of Wind Global. They have different group of expertise where they like group of radiopharmaceuticals, which is a big industry, and there are many applications as he already mentioned in food, and IAEA doing a lot of research, and I like Women in Nuclear has women from different such nuclear industries, like some doing using neutron activation methodologies, doing ocean studies, marine studies. So yeah, nuclear is quite helpful in multiple industries, and that's a great point, that if we are not having just climate change related discussions, we should point out always the applications nuclear has to play in medical, food, or so many industries. So that's really important to educate people about it, and kind of, we say like they're just focused on red waste, so kind of just take them away from that, and discuss more about other applications. Yeah.
Let's go. Do you want to say the question again?
It's mainly that we are always talking about energy or power production, but what about
What should we do?
non-power applications?
Okay, non-power applications. Well,
Sorry.
non-power applications of nuclear. Well, we can't ignore the nuclear medicine that there is in treating cancer and other diseases that may appear. Radiotherapy is unanimous. There's nobody against it. Like, when done in a controlled manner, we know that it can have positive impacts on the health of the people. It's unanimous, there's no doubt about it. We use it every day in our hospitals all around the world. And it is also a point of very exciting in a way, because there's always new research incoming about how to use radiotherapy well and how to get the results we want with a minimum dosage to get the maximum health benefits and reduce all the risks that may be associated with it. I believe that's about it.
Yeah, so we were talking earlier about myth busting, and we've done events in the past at COP around myth busting, and these have always been at a nuclear pavilion. Now, tomorrow it's really exciting. We've got an event at the SDG Pavilion, which is Ask Me Anything Nuclear Energy. And so the SDG Pavilion is looking at all of the 17 SDGs, which covers everything from energy to health to poverty, and it's an opportunity for people to ask about nuclear energy in that context. So someone on the panelists is a more specialist in applications of agriculture and medicine, so it's an opportunity for people to ask those questions. And it's really exciting to have a pavilion. It's very, in previous years, it's nuclear people talking to nuclear people. And what's changed this year, I think we've managed to start getting events at people that have nothing to do with nuclear, and we're really opening that conversation with youth. I'd also like to share some of the myth busting that we've heard and get it back to fusion, because I think some of them are challenging for fission and even harder for fusion to answer. So I think the two that are really challenging and a fair comment is cost and time. Do we have enough time, and is it going to cost too much? Because we're talking about radically changing our energy system now. Like we have to do it in the next 10, 20 years, next 5 years to really make a big difference. And a lot of people are challenging that nuclear is too slow. And I think when you look at the Western world, they're right. It's too slow, and it's a problem of our industry. And we've lost the skills, we've lost the know-how. We're not doing fleets anymore, so it's too slow, and it's also very expensive. Everyone knows that. So it's hard to. We have examples where we can overcome that, and we have plans. We can demonstrate that it can get better, and we can solve it. But when you talk about fusion, I'd say those two issues are pretty powerful. In terms of too slow, it's always 30 years away. Right now, maybe it's 10 years away. But there's also the stage of, okay, if we solve the physics, great, I'm confident that's going to happen. But then can we solve the commercial, economical aspect? Can we actually create power from fusion at a cost that is comparable to renewables plus storage within a time frame that makes difference? Because I know 2050 isn't the end. I know we have to then go into carbon negative after that. We're going to need more and more energy. And when we talk about our energy mix in the 2100, 2200, it's really it could be anything. It could be dominated by fusion. We don't know. That kind of future is difficult. But in the I guess it's just that challenge of cost. If someone asks you, and time, why are we messing around with fusion? We need to focus on other things, because we have that same problem with fission. People ask us that question, and I think we should be investing in it, absolutely. But I guess I'd love to hear, are we going to get there in time that we're going to actually support getting to net zero by 2050?
I can say something about the cost that was taught for me by a professor from Norway, Jonas Noland. That is like, nuclear energy is an expensive way to get cheap energy, whereas solar and wind are a cheap way to get expensive energy. And why is that? That is basically because of the storage. Since solar and wind are basically intermittent, we need some way to store the energy when there's too much, and also store it for when we need it later. And right now, I believe that there's the battery technology is not there yet, or if it's there, it's at extraordinary out of budget prices to keep a grid running, and only available in small scales. There's this amazing thing that is done that is actually pumped hydro, but it also has limitations on energy efficiency and other problems. For example, in Portugal, we have droughts, and according to the provisions, like in the future, we will get even more droughts because of the climate change. And so we need the water. We can't just let it stay there. We need it to grow crops, to get agriculture going, and that's basically it. You have something to add?
Pump storage is 97% of total installed storage capacity, and 99% of total installed total energy. So like the output, the rate of that you can power, and then how much it has. So batteries are like a tiny drop in the pool at the moment. Pump storage is the powerhouse of the storage world.
Yeah, I was just thinking about the 2 points you mentioned, and the time and cost. So they are tough questions, and I don't have good answers for that. But have we tried to answer the question on the time that if you see all the solutions to the net zero problem by 2050, which people have presented, there is probably no credible solution without nuclear, right? So yes, sure, like it's a tough thing to make it practically happening. We are all working towards it, but we are part of the solution, and we have to. And when I say about nuclear, it's both nuclear fission and fusion. I don't think that the kind of technology which we are working right now is going to be the pristine solution to be like part of this movement, but it's the starting. And as we go with the new and new nuclear power plants over years, we will keep in evolving in our technology and hopefully making better and better impact to this, to the whole equation, let's say. And the second part about a small point which you mentioned about the technology in West being slower. I think it's the right time that we recognize that and start tapping into the youth energy we have in the East. It's right time that we start talking more about these fundamental problems and how we have to approach it together worldwide in places like India, in places like Middle East, in places like China, if I may go ahead and say that, because there is barely any other credible solution than doing that, in my opinion.
I would like to add to the cost part. Most of the cost associated with the nuclear industries are because of the delays, because of the policies, because of the many licenses they have to take. So one of the solutions is that we build more units at one place and twin units. When two reactors are nearly same. And SMR, small modular reactors, and micro reactors are a wonderful solution to this time part. They are now SMR. I have seen this. I have seen in my country as well. They are more interested in building. Even we had this conversation today with U.S. Florida Senate, somebody from there, and they're like they are not building any more big nuclear reactors, which is not the solution. I understand they should build more big nuclear reactors, but they are saying that they are building small modular reactors because it takes less time to build them, and because it's factory built, assembled at the location. Micro reactors can be just put anywhere you want to install them, so they can be built very quickly in the industries, which solves a lot of issues related to time. And I'm really hopeful that small modular reactors, which they can work for countries, small countries in Middle East, in in Africa, they might not work that well to meet the needs in big countries like India, China. We need to have big reactors. But yeah, the time constraints associated with the large reactors can be really, really solved with these new advanced small modular reactor technologies.
No, just you have rightly already mentioned that 2050 is not the target, because 2050 is the target where we are trying to bring that low, but the energy requirement will keep on growing, which is an exponential thing. So if you say fusion is when it will come or when it will be the part of solution, for me it depends. If you take it as an perspective, fusion will be the part of solution, surely, but until it's coming at a commercial scale, fusion has to take it forward. So it's in terms of a strategy, that there is an immediate solution, there is an intermediate solution, and then there is a long-term and continuous solution. Then fusion basically takes care of all these long-term and carrying forward solutions. But that doesn't mean that fusion doesn't have a role to play for me, or renewables don't have a role to play. Each of them have their own role to play. And this cost thing is coming again, which was the part of yesterday's discussion as well. It's mainly because fusion has always been seen as the lab project. I'm sorry, as a lab project. And when you talk about lab project, yes. So as a lab project, it's a different perspective, and there you don't think about cost because you are focusing more on the development part. And when as the scenario is changing with the recent announcement at the COP that now people want to go in the industrial mode, it will be definitely faster. I would take one last discussion, and then it's time to, I would say, close the session. That yes, enjoy the music. And the question is, what is your take or takeaway from this COP, and of course from this discussion? Then what will be your final remarks, maybe? Yes, please.
One of the biggest takeaways I took from this COP was in the workshop I had, where we talked about innovation. And so innovation is fundamental for society, okay? we invented the wheel and other stuff that are useful, very useful, and make our lives so much better. And we want innovation in basically every point, be it fusion, be it fission, or be it batteries, be it wind and solar. We want them everywhere because they make a world a better place, and we want it. But what we also need to get clear is that what are our priorities? And if our priority is decarbonization, we need to get innovation in implementing the nuclear energy that is readily available and ready to turn into the grid. And as much as I love and I hope for fusion to work, it's not there yet. And for now, we kind of need fission, at least until we have fusion. And I believe that's basically one of the topics we must address, which is innovation in implementing more nuclear fission into the national grids and worldwide grids in a way.
Yeah, so this is my third COP. And I think for me, what's changed the most from the previous ones that I think is really positive is that we're a youth-led group. We consider ourselves like youth activists, and we want to be part of the youth movement. But in previous years, we were kind of we were sort of shunned. We were kind of to the side a little bit. I didn't feel comfortable with other organisations. I felt like almost ashamed or embarrassed, or talking to people. It was difficult to say we're from the nuclear industry because you're almost like ready to defend yourself almost. And this year is the first year that we've had joint events with other really youth organisations like SDG 7 Youth Constituency, and it's the first time I felt part of the wider youth movement and recognised as like part of it. So I think that's really exciting, and that's part of the acceptance of nuclear as one of the solutions. So that's been really great.
Yeah, it's my first COP, and I have seen a lot talk about nuclear, so I'm really hopeful. And I have my takeaway is that we need collaboration for a sustainable future. We need, since our energy demands are ever growing, we cannot shun any power source, not even fossil fuels. We need to reduce them and slowly. And we have carbon capture technologies, which are also very important. We need more carbon capture technologies until we have the fossil fuel power in place. We need solar, we need wind, we need anything. We need biomass, we need geothermal, and we need nuclear, both fission and hopefully fusion in future. My takeaway is this, that it's the high time. Climate change is like the real, people are talking about it. It's like we need to act upon it, and policymakers have to address that the delays are causing creating problems for indigenous people, more to the indigenous people. So, and I have seen a lot of indigenous people who are just rallying and advocating about this pollution in their native lands because of fossil fuel industries. So yeah, I'm really hopeful, and this COP it gives me hope. It really gives me hope that we are going to have a very sustainable future, and it's a beautiful location we are at. So it's a beautiful sunset. I'm really happy and positive for the future.
So I think I have been not at any of the COPs officially. I'm a visitor, so let me address that right there. But I have been observing COPs since the Paris one, and I think over every year I have personally felt that this more and more discussion around nuclear has been showing its impact on the industry. And I have seen it firsthand myself, because it's the same timeline when I have been also trying to enter into the industry as a professional after having finished my studies. And when I was finishing my studies in nuclear, it was gray. The future was somewhat great. Let me be honest there. That okay, I don't know, should we learn a few more things? Should we learn a bit more machine learning and prepare ourselves for the data world? But thanks to COP and a lot of other things which are happening, and they feed into each other, all the nuclear related information, people taking interest again, and also a bunch of unfortunate world events. But thanks to all this, what has been happening is that there is more interest in the industry. I have been able to see it myself, and I feel myself more optimistic and confident that okay, it's the domain to be in. And I think a big part of that is thanks to COP and all the buzz and all the movement we have started seeing with all these organizations, youth-led organizations. That's my perception.
I think COP21 2015 was impacting all of us together. It was first for me as well when I was participating or supporting from outside. COP26 I was virtually there. COP28 I am in person. For me, the right word is, as Gunjan mentioned, the hope, because until before there was no announcement, forget, or leading announcement related to nuclear or fusion. This year, two major ones, plenary, big announcement, or I would say big collaboration, which is like head of states talking together. So it's a big change, and for me, it's a beginning of hope that industry is taking it seriously, people are taking it seriously, policymakers, decision makers are taking it seriously, and of course, I mean, with the right amount of funding, we'll see fusion will be taken much more seriously in the coming time. But thank you so much with your time. This was a nice discussion for me, and we'll keep on collaborating all together. And thank you everyone for joining. Yeah, thank you.